Hello everyone, myself Afrin Rufi. Me and my teammate Abhinaya Madhuri are doing embedded system internship in EMERTXE Information Technologies, and today we are here to present about our project and about our internship. Our project title is Washing Machine Simulator using PIC16 F877A microcontroller. In this, we have designed a washing machine using PICSimlab, and the objectives are to design a user-friendly control system for a washing machine that can allow us to select different washing programs using the digital key inputs and create a real-time display mechanism to show the current operation status and the remaining duration, including the safety features. Here we have designed a washing machine exactly which can displays like the washing machine we use in our daily life. And coming to the contents, first we will go with the introduction of embedded systems and then embedded C, and then about PIC16 microcontroller and peripherals and the software tools which are used for the project and the functional requirements, and then conclusion. Introduction. Coming to the introduction of an embedded system, an embedded system is a combination of hardware and software which is designed to perform a specific task. Unlike the general purpose computers, embedded systems are used to perform the specific tasks under real-time constraints. They are practically optimized for performance, efficiency, and reliability. These systems are found in our daily life also, like microwave ovens, medical instruments, washing machines, automobiles, and etc. At the core of the embedded systems lies upon the microcontroller or microprocessor that can be used. The microcontroller or microprocessor that is used in the embedded system is pre-programmed. Coming to the types of embedded system is mainly classified into two types, which are classification by purpose and application needs, and another one is classification by hardware capabilities. Classification by purpose and application needs is classified into four types, that are real-time, standalone, networked, and mobile categories. Real-time systems are time critical, while standalone systems are independent and perform specific tasks. Network systems communicate over a network, and mobile systems are portable and designed for mobility. And the classification by hardware capabilities is divided into three types, which are basic systems, intermediate performance, and advanced performance. They can also be known as small scale, medium scale, and sophisticated scale. These categories are primarily differentiated by performance and complexity of the microcontrollers or processor they employ. And next is Embedded C. Embedded C is an extension of standard C programming language specifically tailored for developing software for embedded systems. It provides features for interfacing with hardware, managing memory, and handling real-time constraints, making it suitable for resource-constrained devices like microcontrollers. While based on C, it includes extensions for direct hardware access, fixed point arithmetic, and interrupt handling. And the programs written in embedded C are typically optimized for speed and efficiency. The language offers fixed size data types, limited runtime libraries, and minimal abstraction to suit embedded platforms. Developers use embedded C in systems such as industrial machines, smart appliances, and IoT devices. Embedded C is also a fast and time efficiency coding language. And these are the basic differences between C programming and embedded C programming. Coming into the C programming, it is a general purpose programming language. Like embedded C is an extension of C which is used for embedded systems. And C can run on desktop and server environments, while embedded C is run on microcontrollers and microprocessor. That means the code whichever written in C, that will run in our system. But whereas in embedded C, the code whichever is we have written, the code will be dumped into the microcontroller, and based on the code, the microcontroller gives us output. In C, C is portable across platforms and architectures. But coming to the embedded C, it is highly dependent on hardware architecture. That means the architecture of microprocessor or the microcontroller. C focuses on software programming concepts, while as embedded C focuses on hardware-software integration. Data types in C. In C language, data type means that the type of variable, the kind of a data of a variable is means to be stored. It means that whatever the data is stored in a variable, we have to know what kind of data it is, whether it is an integer, it is an float, or it is an character. That's why the data types are used in C. Selecting the appropriate data type, we should to program the code, we should to use the variables, we should use appropriate data types. For example, using int to hold decimal values may lead to an error, and as it discards the fractional parts. Data types also make code easier to read and maintain. By using meaningful data types like character, char for characters, or float for real like that, and int for integer, the purpose of each variable becomes more understandable to both compiler and the programmer. Here is the flowchart of data types. The data types is primarily divided into three types, that are primitive type, derived type, and user defined type. In primitive type we have four types of data types. They are char, int, float or double, or void. Char is for character. To store the character type of data types, we use char data type, and int is for integer, float or double is for real numbers, and void is for a void data type. And in derived types have three types. Those are signed, unsigned, and long double. Signed means the integer or character or whatever which is it is signed, whether it is plus or minus. And unsigned means it is not signed. And coming to the user defined type, it has array. In array we have three types, that are struct, union, and enum. That are structure, union, and enumerate. Operators in C. The operators are a function that is defining between two variables. We can say that they are like special symbols used to perform operations on variable and values. C supports various types of operators, including arithmetic, relation arithmetic, logical, assignment, and bitwise operator. Each type serves a specific purpose in processing data. In C, we also have the decision-making statements like if or while, helping control the program flow. Conditional statements in C. Conditional statements in C are used to make decision in a program uh, based on whether a condition is true or false. Like we will have some conditions in programming that can be true at some times, and that can be false at some conditions. To make to control the execution flow of execution and allow programs to respond differently, we use. And coming to the PIC16 architecture, and in PICSimlab the architecture will be like this. We have used PIC16 F877A. Here you can see that there are several interfacings between the PIC16, First one is GPIO, which is a general purpose input and output. It is a bidirectional register. And I2C. I2C is for interintegrated circuit, and LM35 is a temperature sensor which gives inputs to the PIC16 as it takes the temperature sensor takes the temperature as an input, that is like it senses the temperature. And A to D converter, ADC is for A to D converter, RS232, and LEDs are used as output. The LED is turned on or off, will let us know about the output, that is the output is verified or not, it is working or not. But and there are also other peripherals like buzzer, digital keypad, SSDs, matrix keypad, and CLCD. We will know about all of these now. Coming to the interfaces, the first one is LED. Sorry, it is LED. And coming to an LED, it is a semiconductor device that emits light when the current flows through it. It is, as I had said, it is the one of the most commonly used electronic component to indicate the status whether the output is correct or not, by lighting or by emitting the light. When current passes through the LED in forward direction, electrons recombine with holes and release energy in the form of light. This process is known as electroluminescence. Here you can see the diagram of an LED and its parts. Whenever the current is passed through the LED, the electrons and holes are combined here, and whenever they combine with the electrons and holes are recombined, they release the light, they release the energy which is in form of light that makes the glow LED. And CLCD, is a character LCD, which is a display device which is used to show the alphabets or numeric characters and symbols on its screen. It is widely used due to its simplicity, and it's also is a low power consumption and easy interfacing display device. The most common types in CLCDs are 16 into 2. That means 16 into 2 is for the segments. It is saying the number of segments in the LCD device, and which can display 16 characters per line. 16 into 2 means 2 lines which have 16 characters of each line. And we also have other LCDs like 16 into 4, 16 into 1, and 20 into 4. They are also available depending upon the application needs. And the next one is tactile switch. Tactile switch is a type of momentary switch that provides physical feedback, and that is like a click or bump when pressed, indicating that the circuit is complete. Its function is that completes an electric circuit when pressed, providing a tactile sensation. The construction is typically consists of a base, plunger, contact dome, and cover. It is used in various electronic devices as input devices. These switches typically have 4 terminals, but internally only 2 are connected during operation. When the button is pressed, the internal contacts touch and allow current flow, completing the circuit. When released, the circuit breaks again. And the next one is fan. A fan is a device that creates airflow, often used for cooling or ventilation. It creates an airflow for cooling or ventilation. It can be an axial or centrifugal, among others. The construction of the fan includes motor, blades, and housing. It is basically used in computers to reduce the heat in the systems and air conditioner and other cooling systems. It helps regulate temperature by pushing air across the heated components, preventing overheating and improving system stability. Modern fans are designed to be compact and lightweight and also power efficient, suitable for space limited applications. And the next one is buzzer. Buzzer is an audio signaling device that produces a buzzing or beeping sound. Whenever the buzzer produces a sound to a signal to signal an event or alert. It can be an electromagnetic, piezoelectric, or mechanical. The construction usually includes a coil, diaphragm, on housing. The buzzer basically used in alarms, timers, and other signaling devices. Buzzers are of two types mainly: active buzzer, which generates sound when powered directly, and passive buzzer, which requires a signal. Usually, it can be of PWM and from a microcontroller to produce sound. PWM is nothing but pulse width modulated signal. And the next one is timer. A timer is a device that measures time intervals and can be used to control other devices or events. The function of a timer is to measure the time intervals, and it, uh, the timer can be of two types like analog and digital. The construction of a timer includes a time base, counters, and output control. The applications coming to the timer applications, the timer is used in appliances, industrial process, and other timing applications. Timers works Timers work by counting clock pulses. It takes the clock pulses from the microcontrollers or oscillators and works based on the counting clock pulses. Once the count reaches the set value or overflow or match, it can trigger an interrupt. That is like a toggle a pin start or stop another operation. Most microcontrollers like PIC16 include multiple timers like timer 0, timer 1, timer 2. Each of the timer have different resolutions and modes such as timer mode, counter mode. Uh, Timer mode means the count internal clock pulses, and the counter mode means counts external events. And software tools used. From this, my teammate Abhinaya Madhuri Singh will continue.
Hello everyone, my name is R. Abhinaya Madhuri Singh. From this on, I am going to continue the project. So, let us start with software tools used in this project. So, software tools used in this project is MPLab, XIDE, PICSimlab, and XE8 compiler. So, let's start with MPLab XIDE. MPLab XIDE is an integrated development environment developed by Microchip Technology for writing, compiling, and debugging code for PIC and AVR microcontrollers. It provides a complete environment to develop embedded applications efficiently. The key features include code editor with syntax, highlighting, and autocomplete. Project management tools for organizing files and settings. Support for various compilers like MPLab XC8, XC16, and XC32. Debugger and simulator for testing code on hardware or in virtual mode. Integration with hardware tools like PicKit, LCD, and MPLab Snap. So the second one is PICSimlab. PICSimlab is a graphical simulator used to test and visualize PIC microcontroller based circuits without needing physical hardware. It allows users to simulate both hardware, that is circuit components, and software, that is firmware, of embedded system in real time. PICSimlab supports integration with MPLab, XPICSimlab, and SDCC compilers, making it easy to compile and test C program for microcontrollers like PIC16F877A. PICSimlab is an ideal for learning, testing, and debugging embedded projects in a safe virtual environment, especially useful for students or developers without access to hardware, which means that we can run this online and which makes easy to for us to progress without buying the actual board. Moving on to the next topic, XE8 compiler. XE8 compiler is a C language compiler developed by Microchip Technology for programming 8-bit PIC and AVR microcontrollers. It is a part of MPLAB X toolchain and is widely used in embedded system development. XE8 is designed to generate highly efficient machine coding while keeping the syntax simple and familiar for C programmers. It supports ANSI C, making it easy to write portable and readable code, which can also be helpful for beginners. So, functional requirements. Functional requirement is a topic where we divide the steps of being like which output we have to define. So, power on, this is the switch 5, pause and stop switch 6, navigation switch 4, door status switch 1. These are all given as input to the microcontroller which sends its commands like displaying washing status in CLCD for buzzer and motor. So step 1. As soon as port is reset, print press key 5 to power on the washing machine on CLCD. Wait till switch 5 is pressed. If switch 5 is pressed, powering on the washing machine. As long as we load the project on PICSimlab. Uh, so it we have to first the display press key 5 on power on washing machine, and after we have pressed it switch 5, then the screen should display powering on washing machine, which means that the washing machine has started. The second step, the washing program menu will contain the following washing options: daily, heavy, delicate, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store. Using the keypads, switch 4, we can scroll between the options available. A long press of switch 4 will select the option highlighted between. Step 3. The screen should allow the user to select water level. The water level menu will contain the following displays: auto, low, medium, high, maximum. Keypad SW4, we can scroll between the options available. A long press or SW4 will select the options highlighted with. After the selection of how to wash, in which method you have to wash your clothes, next the water menu will be selected. Like if you want to select a particular one, we have to long press the keypad word SW4, or if you want to scroll them, we have to gently press the SW4 switch. And step 4. Once washing program and water level is selected, provide user options to start the washing machine. If SW5 is pressed, start the washing machine. Display the functions selected and time taken. Then switch to function screen. And after the water level is selected, washing machine provide like we have to provide the user with two options: start or stop. And if we select the switch start, if we press the switch start 5, then the washing machine will start. And if the switch 6 is pressed, the you will go back to the washing program screen. Like you will go back to the step 2. Step 5. Once washing machine started, display the function ongoing. It can be wash, rinse or spin, along with display the time left on the LCD. After selecting the water level and wash program, we'll left with the option like the machine will be start. And it shows the time function in which it is wash, rinse or spin, and the time left. And Step 6. Once all the programs are completed, display notification, program completed, remove clothes on C. So this is the last step. After the washing machine is completed, the buzzer will be activated, which indicates that the washing machine is completed. So the cycle is completed. Remove your clothes. So let's see the clip of execution. So first here we have to select the board, pick Genius. Then we have to select the microcontroller, which is PICSimlab F877A. After we have to select the file in which the code is presented. So here the first step is done. Press key 5 to power on the washing machine. After pressing off switch 5, we can see that the washing machine is powering on, which is a step 2, which is a step 1. And here the step 2 is reveal, like daily, heavy, delicates are part of washing program. So which one we have to select? This can be decided by pressing switch 4. A gentle tap is enough. If we have to select the particular one, if I have to select the echo cottons, I have to do long press to select that one. Here I have long pressed the echo cottons button for 30 seconds. And after pressing it for 30 seconds, I will be directed to the step 4 where we have to select the water level. As we can see, the water level is appeared. Like I want to select auto. So I have to again press the switch for 30 seconds. So after I have selected my water level, I have given it to switch 5 and switch 6. The program echo cottons and the time is started. So as we can see, the function is wash. The present is time. It's showing the time. In case if someone's opened the washing machine while it's working, so we can see that the door is open. Please close the door. The buzzer rang here. And after the door is closed, the counting is resumed and the washing machine is starting again. I mean, it is resuming again. We can see here the function is changed from wash to rinse after a particular time. And after rinse, it is turned into spin. See, the washing is completed, so it is developed. It is showed that program completed. Please open the clothes, and it is redirected to the step 2. So conclusion: the washing machine simulator project successfully accomplished, and its aim of building an interactive, user-friendly control system using the PIC16F877A microcontroller. The system enables the user to choose between multiple washing modes and water levels while providing the current operation and remaining cycle time. This project showcases the partial application of embedded system in automating household appliances. It is emphasized how microcontroller can enhance usability to improve efficiency and offer intelligent control features, highlighting the real-world potential and versatility of embedded solution in modern electronics. Thank you.